Hello again, welcome to the video. So in this video, as we have studied in the last chapter, the basics of set theory, in this one we shall continue our findings and learn more about the operations which we have learned. So just to give a recap, we have learned about the union, which looked something like this. We also have learned about intersection, which looks something like this. And in the union and the intersection, we can see that these two operators operated on two sets or two or multiple sets, and they would give out a set as a result. So we have taken examples before. So A, B are two sets, then A union B, which is this one, represents the set A or B. So in verbal terms, obviously A union B represents the set A or B. Now A intersection B represents A and B. Now when we say A and B, we actually mean the elements common to both A and B. So this were actually touched in the last episode, and we do know kind of what union and intersection mean, but we would try to find out more about this pair of sets, and we would eventually find out how to relate A, B, C like three sets. And for that, what we will be needing is something called Venn diagrams. So a Venn diagram is a set theoretical diagram which we use to represent sets. So in set theory, we actually represent a set by a complete blank circle. So let's say this circle is the set. So you see the space inside the circle, it's basically composed of elements of A. We do not denote them, or you can denote them like this, but it does not actually matter because this whole circle would mean that it's the set A. In other words, we write this whole thing and we write A inside it, which would mean that this circular portion represents the set A. Okay. So Venn diagrams actually mean something like this. So we can draw completely A, and we can draw a overlapping circle which we call as B. Okay. So these two things basically combine to say that A and B are two sets which overlap, that is they have an intersection. So let me just mark the intersection in a different color. So let's say this is the intersection in between them, and this portion is basically A intersection B, right? So this portion is A intersection B, and as you can see, this circle is A, this circle is B, and the portion common to both of them is A intersection B. So this is how we write Venn diagrams, and it helps us prove a lot of identities, as you will get to see very soon. So first of all, let us prove the first thing that we see, and which is very important in fact, that A union B, the number of elements in this set is basically equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. Now this property can be proved in various ways, but of course we would try to find a more suitable way of doing it with the Venn diagrams. So how do we actually do it with the Venn diagrams? Let's see. We can write a set A like this, and we can write a set B like this, and obviously when I say A union B, it means the whole of this, right? The whole thing. So it really means the whole thing. This whole thing is represented as A union B. We want to prove that this is equal to mod A plus mod B minus mod of A intersection B. So watch closely that this is mod A, right? So this is mod B. Okay, but this two can be written separately like this. So this basically, this portion is common to both A. So A is basically this whole circle, but only this part plus this common portion, which is A intersection B, right? Similarly, B is basically this whole thing, as you can see here, this whole thing except this intersection part plus the intersection part, which is A intersection B. Now when you add A and B, what you get is this. So these two things add up, and if you take one of them, it makes you the whole thing. It makes you the whole A union B thing, right? So you take this part, you take this part, and you take any one of this. So let's say this part. So one of them is also left. So these three parts make up this whole A union B thing, and we have an extra leftover, which is the A intersection B, because there were two copies of A intersection B, right? And this equation basically gives us, by transferring this thing to the left hand side and writing this in the front, that A union B is basically mod A plus mod B minus mod of A intersection B, right? So like this kind of gives us the natural vibe to what to do, and this is called the union rule. Okay, more naturally, two sets if two sets are disjoint, if two sets are disjoint, that is, they do not have any elements in common, which means basically their intersection should be 0. So this basically means that A intersection B is 0, that is the mod of them is 0, or in other words, A intersection B is basically the null set, or which we denote by phi. If you remember from the last chapter, that we denoted that this is called a null set, right? Now A intersection B is 0, and this is then we can call A and B are disjoint. Okay, A and B are disjoint. So when A and B are disjoint, we can say that the number of elements in A union B is basically the number of elements in A plus the number of elements in B. This only happens for disjoint sets. Okay, so this can be shown as an example like this. So if, for example, say A is A comma B comma C, so it has 3 elements, and while B has like 2 elements, D comma E, and all of these 5 elements are distinct, then obviously n of A intersection B should be 5, which is nothing but n of A plus n of B, right? So as you can see, they have no common element, so obviously that makes sense. So this brings us to the final part of this basic chapter, which is basically to identify and find out examples. But first we would try to understand few of this. A union of B intersection C, where there are 3 sets involved, this can be separated in the distributive laws as follows. This is more of a memorization exercise rather than a proving one, so you can memorize this kind of properties, and obviously we can prove them as well, but it only remains to prove that if it's worthy to be being proved, because it requires a lot of Venn diagrams, and you need to draw 3 of them, and you need to prove both of the sides. Only then will you be able to prove all of them. So this is another distributive law, which basically says this. And this should be union. Yeah. So these are the two basic distributive laws that we can use. And lastly, we can do an example problem like this. If A and B has 5 elements, in common, then what is this value? Then obviously in this type of questions where you have to find the number of elements in a set of, like, let's say A union B, A intersection B, A or B alone, we are always going to use the union formula, which you remember from here, which basically says A intersection B is mod A plus mod B minus A intersection B is mod, right? So we use that formula to advantage, and we see that the number of elements in A union B should simply be equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B, right? This should give us 7 plus 8 minus 5, which is basically 10, right? So the number of elements in A union B is 10. So this gives you a basic and fair example of how to solve this kind of problems, and in future problems we are actually going to move on to the ideas of probability, where actually we are going to use a lot of set theory. That is why this introduction was a bit necessary. So I guess this would be it for this lecture, and please check the description for the downloading of the Britter app, which is a mathematical app where you can use all kinds of statistical tools, and the theory related to this video is also provided in there. So please do check out, and thank you.